Okay, good morning everyone. Let's start with this webinar titled Production Mapping Enhancement in Petrosys PRO 2019. My name is Emilio Spinola. I'm a technical sales and support geoscientist based in Perth. Please note that this webinar will be recorded and will be made available in our website in a couple of days. Please let us know if you have any questions and we'll try to answer them at the end of the webinar. So this is the third webinar of this series. The next one will be Raster to Vector that will be broadcasted sometime next month. So please join us for that one. And so all of these webinars are related to this new release, Petrosys PRO 2019.2. So for today, we'll talk about the enhanced displays of Worldpass segments and a little bit about the improved functionality of Google Maps, and we'll have a short demo on those two key features. So the first of the two features that we want to discuss today, the Worldpass segments functionality. So as you may well know, the displaying Worldpass segments helps to visually identify and highlight any spatial distribution of key producing zones or sands of property. And so it's of course more relevant when we have the directional deviated wells, and that's something that we are trying to help with this new feature. So the feature consists in now we're allowed to display multiple path segments in the same display layer. So the path panel that you are familiar with has been split into the traditional full well path, but now we have added the path segment display, and on the bottom of the screen you see how it looks like. So on the top right you see the individual features that we've been added. So the ability to edit in bulk those segments is a key one to make it easy to use, and that's something that I'll be showing you in the demo in a couple of seconds. So okay, so the other key feature that I wanted to show you today is the bubble maps. This actually was added in Petrosys PRO 2018.3, which was the last minor release before Pro 2019. So the display of bubble maps has been improved. So now we can display bubble maps with source in a variety of formats, whether it's GIS, well data, or database. So now we can, for example, have RxDE or Web Feature Services the input to build our bubble maps. And also the variable selection has been improved, so now you can set the order in which the variables are displayed, so to make your bubble maps look better. So a wider variety of sources is the key feature when we talk about this enhanced bubble maps functionality, and I'll show you a couple of examples in a couple of minutes when we get to demo. So let's show you quickly each of these features. Let's start with the Worldpass segments. So I'm going to open my mapping window, and I'm going to open a DBM file that I have already prepared, and that I will use to show you the key features in this Worldpass segment. So in this case, I'm displaying some well data. This well data is coming from a third-party source. In this case, it's coming from a Petrol project, but it could come from any third-party source that we support. As you can see, we support all of these formats in Petrosys. In this case, we're working with a Petrol project. And before going into the path segment, go briefly to the well symbols tab. I'm displaying the same coloring scheme that I have in my Petrol project. So I'm using the Petrol well colors directly from the Petrol project and being applied in Petrosys, and also reading directly the symbology for each of those wells, right? The same goes for the annotation. It's been read directly from the Petrol project. So let's go to the feature that I want to talk about today, so which is the ability to display Worldpass segments. So in the top of the section is a section that you're familiar with. That bottom section is where we have the ability to add segments. So if we click plus icon on the right, we are able to add segments, and we can limit those segments in a various ways. We can display it from top to top, which is the one that I'm showing you at the moment. So I'm displaying two different tops. I'm going to apply a particular color to that segment, and I'm going to increase the thickness of that particular thickness, or that particular segment. Once I click apply, and I zoom in any of those well paths, so I see that the particular segment that is limited for those two tops has been highlighted. So if I now add some annotation associated to those tops, so I click the two tops that are related to that particular segment, so I see that that particular segment has now been highlighted with a different styling, so a different thickness, a different color, so it's easier to identify the top of the segment that is limited, in this case, by those two tops. So that's uh, how it works. So let's say that instead of being limited a particular segment by two tops, I would like to use other options. So for example, I can limit it between surface and a top. And if I click the plus icon, now we'll be able to add another segment as well into my list. So in this case, I'm going to go from the same top that I had in the previous segment, but I'm going to go onto the buttonhole. So I have, in this case, two segments from surface to a top, and from the same top to a buttonhole. So I apply different style, click OK, and I see now how those two segments are now being displayed with the properties that I have selected for them. So from surface to that top in red, and from that top to the buttonhole in green. So that's how you can play with the segments in an individual manner, right? So, but we can also edit those in bulks. So let's remove these two segments that I have at the moment by selecting them from the right. So I select them all by clicking here, click the minus icon, and all of them have been removed. So if I click in the bulk adding intervals and select the zones, and then I right click, select all, and click OK, then I have added all my zones to the list. So I have segments for each top and base that I have available in my well data in this particular case. So if I click apply and then zoom in any of them, so I see that there are different colors associated to each one of those segments. So if I want to edit them in bulk, I click this box here, and whatever modification I do to any of those segments, it will be applied to all of them simultaneously. So I changed the color to the Petrosys and changing the thickness. So once I change one, it changes all of them. So now let's also add the well tops. Let's set it to all. The color is also Petro formation, so we have consistency. So I click apply. And now we can see that all of the segments are being displayed with the coloring scheme from the Petrosys and the formation top as well. So that's a quick and easy way to display all of the tops available in my data source by adding them in bulk and by also edit all of those segments, path segments in bulk. So instead of going by one, we can do it in bulk. So let's say that I want to just get rid of one. So I disable the bulk option, get rid of the one that I want to eliminate, click apply, and we keep the path segments and formation tops that we want to portray in this particular map, right? So once we have the segments and the tops with the style that we want to display, return, for example, a relevant grid that is associated to the particular map that I'm working with. And just as an example of how it might look like. In this case, to highlight the segments, I have displayed the grid in a gray gradient. So once we do that, we go to select our map template. So in this case, I'm choosing this one that is called PowerPoint. So it is as easy as adjusting our layers, then selecting a relevant map template for style and for extent, and then we have pretty much our map ready to 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 as a final map, right? So and to be output as a raster or into insert into a PowerPoint or to print into a plotter, right? So that's basically what I wanted to show you regarding how to display path segment, which has been added into Petrosys PRO 2019. So going to the second feature that I wanted to talk today, which is the bubble map functionality. So I have prepared a couple of examples, using different sources. The first one is creating bubble maps using a web feature service, so vector data from a map service in the internet. I'm pulling directly from the internet to create the bubble map. So in the background, I have a raster image, which is coming from a web map service. This particular one is a web map service from the Geological Survey of Western Australia, and I'm displaying the surface geology. So that's something that we added a couple of releases ago as well. So I have that in my background, and on top, I'm going to display a bubble map. As you can see, now we have the ability to have multiple sources. So Wells data sources, database, or GIS data source. In this case, it's a GIS data source, and we support all of these type of data sources for GIS. In this case, I'm reading the point data from a web feature service, also coming from the Western Australia Geological Survey. So I connect to that particular service that I have already saved in my catalogs for a quicker display. Then I need to choose the feature type. Of course, it needs to be a point type of feature, so we can create bubble maps around it. In this case, I'm using the type called drill holes, and I'm adding a variable into an attribute into my variable list. It has to be a decimal type of attribute to be able to compute the bubble maps. So as I said, in this case, when using the depth of each one of those attributes, then I set the coloring style. In this case, I'm using a gradient, so the gradient will be associated to the variable that we select. We specify annotation parameters. In this case, I'm choosing name value and selecting an alternative posting name. And finally, we set the scaling parameters. In this case, I'm using a logarithm type of scale, and choose a reference value and reference diameter. Once I'm happy with the parameters that I have set, click OK, turn on the layer. And as I said, we're reading the input data directly from a feature service, vector data from the internet, so it could take a couple of seconds. So now we have the display of those bubble maps. And if I zoom in just to show you a bit better, so each of these bubble maps, the size is associated to the parameters that I set on the panel, and it's reading the well name and the set value, and the size of the bubble map and the color are associated to that particular parameter, right? So that's how easy it is to create a bubble map from web feature service. So let's go to the second example. In this case, I'm going to create the bubble maps reading the data from a well source. I have this well data that again I'm reading from a third-party source. In this case, it's also a Petro project that I'm reading directly, so I'm not importing the data into Petrosys. I'm just reading directly from the source, and I'm going to create the bubble maps reading directly the data from the source. So whenever I update the input data, my bubble map and my final map will be automatically updated because it's a dynamic link to the source, right? So this is my input data. I'm going to display the bubble maps. As you see now, the data source, instead of GIS, is wells. I choose my well data source, which in this case is Petrel, connect to my Petro project, select a subset of wells based in a Petrel folders, set the data source, which in this case will be formations, but it could be zones or well header. Then choose the data type, which is formation, and then I choose the relevant formation that I want to use to compute the bubble map. So I'm going to the list of variables associated to that formation. So I'm going to choose the set value associated to that formation to compute my bubble maps. Then I fill the parameters as needed, apply, turn on my bubble maps, and that's how we have created a bubble maps associated to the set value of that particular top reading directly from a third-party source, which in this case is a Petro project. So if I save my map here and then I change the input data, then the map gets automatically updated because it's a dynamic link to the source, right? So the last example that I wanted to show you is using Excel data as my source. So in this case, I'm trying to compute some pie charts. So the only difference between pie charts and the bubble maps that I showed you previously is that I'm selecting more than one variable, and when I do that, it creates some pie charts. So the data source, again, GIS. In this case, we set it to Excel as our input source. We point it to our Excel spreadsheet file. Petrosys does its best to recognize the format, but it may need some tricking to take the right format to read it. We add the variables. In this case, as I said earlier, I'm adding more than one variable, which are isopacks 1, 2, and 3. And if I go to my list, my preview of data, these are the ones that I'm using to compute those pie charts. So once I've added those variables into the list, I just choose the style for each one of them. So for isopack 1 is green, for isopack 2 the solid field is red, and for isopack 3 the solid field will be blue. And once we do that, we go to the annotation and scaling parameters. We set the parameters as we want to set them. And once we are satisfied with those parameters, we click OK. So let's change it here to name and value so we have more information. So this is what we get, right? The size of the bubble map and the charts are associated to the variables. In this case, there are 3 variables, and that's how we compute pie charts in Petrosys using Excel data as our input. So that's all that I wanted to show you for today. Thank you for your attention. I'll check if there is any question on the log. Looks like there is no question. Well, thanks for attending the webinar. Just a reminder that we have a client portal, and you can check the different workflows that we have there in PDF or short video format, and I encourage you to have a look because there is a lot of information there that could be useful to you. Okay, thank you very much for joining us, and hope you can join us in the next webinar. Bye for now.